Find the rate I. In this problem, we are provided with a cash flow diagram which lasts for 7 years. In this diagram, we notice there is a negative cash flow which becomes increasingly negative each year by the amount G, or negative $500. If we were to compute the quantities, we know G equals negative $500, 2G would equal negative $1,000, 3G would be negative $1,500, and so on. When a cash flow is continuously incremented by a fixed amount each year, G, this is often called a gradient series, represented by the variable G. At the end of year 7, there is also a positive cash flow with the value of $11,250. Unless otherwise stated, it is assumed that the net balance in the account equals $0 at the beginning and at the end of the cash flow diagram. Therefore, we need to determine the rate or the rate of interest of the account I such that the net balance in the account equals $0 at the beginning and at the end of the cash flow diagram when provided the values of F and G. Since the final net balance equals 0, we'll begin by writing out the equation for the future value of the account. Since the rate I we're trying to solve for is buried inside the discount factor, we'll first solve for the discount factor. Since the discount factors are always positive, we'll plug in the absolute values of variables F and G, and the discount factor equals 22.5. This makes sense because variable F is positive, G is negative, and the discount factor must be positive. This particular discount factor is sometimes called the uniform gradient future worth discount factor, which equals the quantity 1 plus I raised to the n minus 1 divided by I squared, all minus n divided by I. In this equation, we know n equals 7 because there are 7 years, or 7 compounding periods. Next, we're left with one equation and one unknown variable, I. This equation is not easily solved by hand, primarily due to the 7 in the exponent. Therefore, we'll look ahead at the 4 possible solutions and choose the rate I, which makes the left-hand side of our equation equal to 22.5. To organize our calculations, we'll create a table to track the value of the rate I, and to track the left-hand side of the equation when using that rate I. For a rate of 4.03%, the left-hand side of the equation equals 22.469. If we test the other 3 rates the same way, then we can compute the left-hand side of the equation as before. And it turns out that the rate of 4.11% yields a left-hand side almost exactly 22.5. When reviewing the possible solutions, the correct answer is B.